I'm Jake. I'm with the Agentic AI Foundation with the Linux Foundation. I'm also supporting the CNCF for the last couple of years. Today, I want to talk about GitOps and how it applies to agents in agentic deployment. One of the patterns that we have seen in the last year or so, going on 2 years, is that seems that GitOps is being used, put to the side in place of agents, right? Which is an operational broken pattern. There's a ton of problems with that. So I want to go over some of the problems that we have encountered, pulling some case studies that I put together, and some possible fixes that I've seen from the community to help you, not replace your agents, whether it be Flux or Argo CD for your deployments, but instead use them to put checks and balances on your agents, right? So quick overview of who I am. I'm with the AIF. I am from New York, KCD Lima speaker. Um, my background is computer science, AI, and I love certification. So if I see something that interests me, I take it because I love it and it interests me. So learning is something I love doing. I assume everyone in this room is the same way, right? So this is an incident from Replit, right? It was in July last year, actually February last year, if I'm not mistaken. So an agent with write access and no guardrails uh, wiped out 1,206 records, and it produced 4,000 fake records to cover for that, right? And there were, yeah, it's a bit ridiculous. Funny thing I encourage you to look it up. I have the title of the piece there, but there were no guardrails put in place, right? There was nothing done to protect this or prevent this or to revert this. So this was kind of disastrous. Another example is MoFat versus Air Canada. 812 Canadian dollars were awarded to MoFat over Air Canada because Air Canada argued that the large language models actions were its own and they weren't responsible for it. But they set the precedent that that's not the case. Damages were awarded against Air Canada, and that argument was just thrown away. The pattern we're seeing here, and the less, what I'm trying to drill down is that agents are not in isolation. You deploy them, you're responsible for the damage they do and the work they do, positive and negative, right? So the way things were before is that everything was deterministic, and this was before a coding agent world, right? So same operation, same sequences, things can be repeated, and you were guaranteed to get the same outcome every single time, right? So scripts were very much, run the same thing, run the same output, provided they were in the same environment, right? So humans also review changes before it all merges, and pipeline does what it's told. It's very predictable. So now things have changed. So execution paths are changed, and we pray that the outcome is the same for the most part, right? Agents do pull live context, and they also spawn unique sandboxes per task. So creating their own VMs within your machine or your VPSs. No two executions ever look identical. So if you look at the thinking of the agent, you'll see that sometimes they take different routes depending on the model, and even the same model, to be able to get that same result. So the system achieves that desired outcome, but it's doing so mostly because of the human and because you're putting a defined goal, right? So GitOps helps with this, right? And it's more important than ever. It's not something that's optional because it has 4 properties that are mapped directly into the philosophy, which is declared, version, pulled, and reconciled. Some of the things here I mentioned is agents read state, target state. Every agent commit is trace, and no authorized pushed, unless a human reviews it, and every agent drift is corrected and accounted for. So these are 3 studies from Forrester. So the big thing here is that you would be able to get people like organizations using OpenShift Platform Plus have achieved a 203% ROI using agents with GitOps deployments, and that's on the low end. On a more aggressive number, you're looking at 703% of ROI using the tools that they have, implementing GitOps principles, and putting checks and balances on agents, right? So, and the reason why is because of the 3 architectural wins that GitOps brings, which is pull replaces push, less security concerns there. Git replaces kubectl, so you can find out who did this and who went into no more looking into who went into the cluster and made a change. And then drift becomes a bug, but it's something that's correctable, right? It's something that can be easily rolled back and corrected. Now, the problem is that with agents handling these things, we have a ton of regulations that are emerging that are going to be taking effect. Like, for example, the EU, the newest EU regulation is going to take effect in August 2nd. So we have DORA, NISC2, SOC 2, and SLSA. So these are all things that GitOps can help with because they do help with accountability, tracing, etc. But agents, if you're strictly using agents for deployments or giving them free reins, it's something that can't be accounted for. So the basic point I'm making is that Kubernetes clusters were not built for AI. They were not built for agents to go in and start moving freely, start working things, start moving pods around, making configurations. So the big thing that Kubernetes was good for was for isolation sandboxing, stateful memory fabrics, dynamic GPU scheduling, and observability as trust. But AI and agentic workloads don't have these by default. So these are things you have to build into the agents and the agent deployments. So these are examples of things that agents should do. This is what you want them to do, but not necessarily. Besides this, anything needs a human review. So detect and collect information. You want it to do reasoning, open a PR, and I'll get into that PR part later, where to make sure that these are meaningful PRs. Validation, CI validation. You see this all the time with, for example, GitHub Actions and Copilot, right? GitOps reconciliation and supply chain and signature management, right? These are all things that agents could definitely handle, and these always need a human in the loop. So this is one thing that we've heard a lot of in the last year, is that review fatigue is a real thing. It's estimated that AI is producing most of the commits on open source projects across GitHub. So this is creating a problem where the human is becoming the bottleneck. But are we really the bottleneck? Or is it that we are not prioritizing the PRs that are being submitted by the agents, right? So there's some that are low risk, auto-approved, very small things, documentation, right? Indentation, things of that. Medium risk, which is one reviewer, new services, new dependencies, etc. And then high risk, which requires a team to look at, right? And then I would also suggest that there's a tier perhaps that is anything under that simply does not need any review. Why is it even a PR? Can it wait and it can be bundled together to something that's bigger? That way you're not throttling your team as they're reviewing these PR that are created by agents, right? Because when you're sitting there and you're coding something and you're submitting a PR yourself manually, you're thinking about things, you're putting it all together structured, and AI will submit 4 or 5 in one go. And that causes a big problem. And imagine that on an organizational level with over 5,000 engineers. So this is a problem, right? So this is a case study from Root.io. They presented this in Atlanta. So they pointed out that they were able to fix AI agent security vulnerabilities at scale by using Argo and Git. So they were able to use Argo CD, Argo workflows, and AI agents. So they spun up hundreds of agent workers on demand, and they scaled it to 0, and they configured everything in Git. So all the agent prompts, all the agent goals were on Git. So they were able to get a full audit trail. So when something was deployed, the prompts were there, and they were able to figure out the chain of thought of why the error occurred. And if an error occurred, they were able to roll back immediately, not using agents as the de facto reconciliation process or the CI/CD delivery tool. So there's another thing that happens is that if you're not in the loop as well, you can also have agents hallucinate things very early in the process. And what happens is that this creates a chain reaction throughout the deployment where everything is wrong. So if you I would recommend verifying, abstract, working on different YAMLs and integrations for agents, right? Putting enforcement as code is super important. So if you're using Kyverno, RBAC, and then make sure you have protection flags as well. So this is another example. This was actually from, I believe this was, I forget the gentleman's name, but if you look it up, they just had this talk in KubeCon, Julian Seaman and Corey McAllard. Very fascinating, where they were able to show that an error very early created all types of problems that wasn't found until later. And essentially, without putting guardrails in place, this could have, this could have been prevented if they put these guardrails in place. So, as I mentioned before, the reasoning chain, you're not able to understand that. You're not able to understand fully why an AI decides to take a certain action. Um, so your first thing is to make sure you evaluate everything as code, everything as markdown. Make sure you have schema assertions. Make sure if you are able to have a second LLM, give it a second go with very strong prompts and guardrails and goals. Be able to check each other's work, and make sure you have a blocking gate. Normally, that would be some type of deterministic code or a human in the loop, right? So always implement production trace monitoring, multi-turn evaluators. Make sure you have a rollback mechanism in place, and also length use trace linkage as well. So as I mentioned before, having your prompts in Git is very important, because that way you can find out, what what makes sense to me when an LLM went wrong and it completely destroyed a whole cluster that was serving this region. So let's take a look at what the prompt says and go back into Git. If not, you're just kind of doing it through a chat window. You have no accountability there. Everything must be accounted for. Everything must be put into Git. And that's the best way to do things. You will want to have semantic versioning of the prompt as well. And then make sure you also have a CI evaluation, and make sure you can log its traces logs, right? So without having these prompt ops, without this, you are risking editing of software without any version history. Your regulator, if you're pinged by that, they can ask for this information and you don't have it, and you can risk fines and even worse. Um, an engineer who essentially was the brain behind all things, they leave. There's nothing they leave behind, and you are in the dark because you don't know exactly how they were working these things. If you don't account for this on a fundamental layer through Git, then you're risking a ton of things that could be detrimental to the organization and to your customers. So, quick look at the EU AI Act. It's going into effect August 2nd. So it has full risk AI obligations. So one of the things that Git addresses is that, for example, continuous risk management lifestyle. Git solves for that with reconciliation loops and PR gates. Data governance and bias mitigation with pachyderm data set and refs in Git. There's also the annex for technical documentation. Model cards are as PRs, how Git solves that. And it goes on and on. The point is that everything in this act is solvable with Git at its core. So this is a quick look, right, at agents. So 33% of enterprise apps will include agentic AI by 2028, but 40% of agentic AI projects will be canceled by 2027. It seems like this contradicts itself, but it doesn't. So what this means is that this will be consolidating. Those who are good at using agents in production are going to get better at it, and they're going to be deploying more of it, while other companies are simply going to be left out and going back to the old ways of doing things. That is a gap that is measurable, and we're seeing it right now. And one of the ways, to be able to solve for that is to employ Git at the very GitOps at the very basic level when you're deploying agents to help solve for these problems. That way you are within the 33% that's growing their use and doing it in a responsible way, in a way that is scalable and sustainable, that can give you actual ROI, versus the 40% who are experimenting, deals with a lot of shadow AI, and that they essentially don't, they see it as an experiment that failed. And perhaps they wasted a ton of money on. So to solve for this, us at the AIF, who I represent, we have 3 founding projects. MCP, you might be using this daily. Goose, which is an agent, and agents.md, which is a markdown format for agent behavior. So these are some of our members at launch. We also just recently brought on Agent Gateway. So Lin Sun, who did a keynote today, was very instrumental in that. But we are also looking to work on standards, on protocols, and bring these things together so that way it's not the Wild West anymore. So we can standardize things the way that Kubernetes is standardized across different deployments and across different industries. So these are 7 questions that enterprise deployable agents must answer, and GitOps already has them. So essentially, I'm presenting to you questions that didn't exist a couple of years ago, the problems that we already solved years ago. And what this means, we have to double down on GitOps. So first thing is who deployed this agent. So let's take a look through the git commit and the signed identity. What model does it use? Look at the declarative manifest and its version in Git. So we can see when it was deployed, when it was changed, like someone decided to use Quen versus using Minimax, for example, right? Or using Sonnet or Opus, right? But you get a nice trail of when these changes took place. So what tools can it call? So MCP server list committed to the repo, that's absolutely essential. What data did it train on? So that's another thing you're able to take a look at. Who approved this version? PR reviewers, code owners are there. When did this behavior change? The reconciliation log and online evaluation pillar on top of the reviewer notes as well. So that would be super helpful. So these are all things that if an auditor came and asked you for, you would be able to present to them up front. Otherwise, you'd be really scrambling to get this information, right? And how do we revert? So obviously Git revert, right? So right now, Git essentially made infrastructure faster, safer, cheaper. I'm arguing that GitOps is necessary nowadays. It's no longer a nice to have or an experimentation. I think it's table stakes, and especially in the age of agents and AI agents, it's absolutely necessary having repeatable patterns, traceable patterns, because the challenge with GitOps for declarative deployments, right, versus with agents is that you have to figure out why an agent did something. You have to treat it like an employee. You have no idea why people are this way. If anybody's familiar with like Silicon Valley, to show, sometimes dashes versus zeros, it's a thing, and you have to figure out why it acted that way. So there's more you have to account for. So if you're not implementing GitOps, you're really risking a ton of stuff. So this is a 90-day pilot for you to pitch to leadership, right? To them, they might see it as another slowdown or not abstraction layer. But have one team use one cluster, Argo CD Flux, Kyverno, external secrets, have them deploy with that, right? And then progressively add more rollouts, add more projects, expand your use of Argo in its different aspects. And then you add your AI workload as well with K-Serve, the LLM, or if you're using models through API, et cetera. So that way you can have a progressive look at how things are working, and how to essentially scale that and what things you have to correct. So takeaway here is platform decisions and AI decisions are coming together now. They're not coming, they're here. Most of the keynotes were on agents. And well, not everyone has the ability to have small clusters, right? One thing, if I do encourage you, if you do talk to the keynote speakers who were here earlier today, ask them and they will tell you they have some type of rollback mechanism and auditability for their agents and agent deployments. And it all starts with GitOps. So yeah, just take a quick look at what we have going on. That's the GitOps working group through the CNCF and the Continuous Delivery Foundation, Agentic AI Foundation. Go check us out. You can also join us at our Discord and add me on LinkedIn if you'd like. So I'll be here the whole evening. So have a good one. Thank you, everyone.